Okay, I've got some sound. I am just up. Okay, let's see who joined me. Discuss our hi, Hannah. Glad to see you. And I'm sure we'll have other folks join us here in a few moments. So we'll get rolling here. Got a few extra moments. I hope you had a nice holiday and relaxing one. We got about 5 minutes now, and I'm sure we'll have some people beaming in. And we'll be ready to go. Let me check my schedule here for a minute and see if I might have crossed everybody up. I'm pretty sure I said this would be a virtual. Yeah. Yeah. Okay. Yeah, we had class. That was the day right after the thing. Okay. So we should have some others join us here. We got about 5 minutes, so I'm going to hang on a little bit here, and then precisely at 11, we'll get rolling. Okay. So hang on just a couple of minutes or so, Hannah, and then I'll start, and we'll go from there. Okay, I think I'm going to go ahead and, yeah, let's see who's joined. Yeah, glad to see you, Brian. Thank you. And I'm going to go ahead and launch this. We're a few minutes early, but that's okay. Those who join us will always be able to scroll back. And hopefully now we're into some semblance of normality after the start of class and Labor Day and my issues having to fly back and forth to Phoenix. So we're ready to roll today. Now, there was no class, obviously, Monday because of Labor Day, and today is virtual class, and then Fridays you had the virtual lab. So I want to take a few moments, and what we're going to focus on today are two cases, and as usual, what I will do in class time is I'll cover a case or two cases. Usually if we're able to meet Monday and Wednesday, I'll do one case at a time, but I'm going to have to work through both of these two cases today. Now, as always, if I go over 50 minutes, you're welcome to bug out if you've got another class or you've got another appointment or something like that, because I'll finish when I finish. This doesn't mean I'm going to go 2 hours or anything like that, but I might go an hour or a little bit over sometimes. And if I do, just take off, and then you can always see the remainder once I process the screencast and turn it into a video and post it at YouTube, turn it into a YouTube video and then post it in the announcements area. So all that being said, we're going to start today. We're going to look at the first is par inc. Okay. And that's over in the case is covered in pages 32 to 54. And this is a maximization problem. Now I refer you over to Appendix 2.2 in the textbook. Now last week we used Goal Seek, which is one of those what if scenario tools. And this week we're going to start to work with the optimizer in Excel. Now, if you go over to, you want to go over to the case backgrounds over in pages 32 to 54, but in Appendix 2.2, which is pages 89 to 93 of the text, they talk about using Excel in dealing with the maximization problem. And so we'll pop back over here for a moment, okay? Now, you're going to see the text refer to this Lingo. Lingo is an online tool that the authors of this book provide through their lab. Unfortunately, the lab is another 175, or I think it was $175 at last when I last checked. And when we have Excel and we can do the same thing, there's no reason not to use Excel. So Appendix 2.2 starts us with using linear programming with Solver. And so what we want to do is let's go over, and you always should have your textbook with you. Now you'll notice, I've got mine online in a thing called Vital Source. You can, if you use Amazon Kindle or something like that, I like an online textbook because I can quickly search for things that I want to find. I can tag, I can make annotations, and the best thing is this: I can rent the book. Many of the publishers today just simply will not send faculty desk copies of books anymore. Some of them will let you have a copy online, say like in a Vital Source for a certain period of time, or you end up renting them. So trust me, the high cost of textbooks is hitting everybody, including faculty. But this Appendix 2.2 is out of Chapter 2, obviously, and it talks about solving linear programs with Excel. Now let's talk about what do we mean by a linear program or a linear problem and using the simplex. All that we're assuming is that the data are distributed in a linear fashion, where let's say you have a chart and the data start and the data are just simply a straight line from the corner of that chart all the way up. That's what it would, or conversely, it's at the top of the left, at the top of the y-axis, and it goes down. So what we're assuming is that the data, that when one thing goes up, another thing goes up, or when one thing goes down, another thing goes down. We're talking about variables. So we're assuming that they have a particular characteristic or consistency. And page 32 through 34 will walk you through that as we talk about the process of what we call using simplex LP. And the authors will walk you through the linear algebra that you can use to plot the problem and all that business, which is wonderful. As long as you understand what simplex LP means, that's what's most important, that you assume that as one variable increases, the other increases, or if they decrease, one thing decreases, the other increases, or vice versa. So you're talking about it follows a linear trend. Okay, the data are distributed like that. Now we're going to walk through this, and this is a maximization problem. Now before we go too much further, here's what I would like you to do. Go over to the Files section of Canvas, okay? And we're going to go to the Anderson Student Files. And there they are, and they're in a zip file. And so we're going to download those files. And now what I do is I show it in my folder. I'm using Chrome. I guess it's done now. It's ready to let me see it. There we go. And I take that zip file and I put it on my desktop. Okay? Now, when you download anything from Canvas, you're going to have to put it on your desktop, which is the easiest place usually to find stuff, and you're going to have to open it up and save it to your desktop. Otherwise, you're working with a temporary file. So if you work with a file and you never saved it to a different environment, i.e. your desktop, the temporary file will upload, but it will be garbage. It's a security feature that they put into Canvas in almost every learning management system. So we're going to open this up, okay, the zip file, and then I'm going to open up chapter 2, and I'm going to find both of the files we're going to be working with today, and they're the Excel files. And one of them is M&D Chemicals, that's M&D. So I'm going to put that right there. And then PAR. I'll grab PAR here for a moment. Okay. Ooh, yikes. I gotta scrub myself back here. Now, what I would do is this, if I were you, is I would open this up. Okay, glad to see the rest of you here. And I'll enable editing. And then I'm going to save this on my PC, on my desktop. And here I'm going to put Harmon Keith, because I'm going to be uploading this file after I've made the modifications to it that I want to make. Okay? So I'm going to do that. I'm going to put this on my desktop. This is the first one, M&D Chemical. I'll close it off. And then the PAR file, I'm going to open it up. And enable the editing. And then I'm going to make sure I save it on my desktop, PC, desktop, and I'm going to call it PAR, and I'm going to call it Harmon Keith. Okay. And put it on the desktop, and I'm going to save it. Now, both of these files now are no longer, these are no longer temporary files. Okay. They are files that are on the environment in my workbook. So there's the PAR Harmon Keith. Let me find the PAR. Let me find the M&D Chemicals. Here's M&D. Well, I probably didn't save it. So I'm simply going to open it back up and do it again. It's probably lurking around somewhere there. And I'll save it as PC, my desktop, and make sure I put it there. And I'll say yes, and I'm good to go. So I should have my M&D Chemical. I've got the PAR Harmon, and I have the M&D Harmon. Okay? Now these files are no longer temporary files. They're files that are on my machine, whatever machine you're using, and I'm good to go. Okay? I'm going to stop for a second. Does anybody have any questions about what we've done so far? Anybody? Okay, I'm going to proceed. Now, as I had mentioned, I'll close this. We're going to be working with PAR Inc. and M&D Chemical. And we're going to be working with, in PAR Inc., maximization. Now, the exercise itself, here's the assignment, okay? And it says refer to Appendix 2.2. You can read this faster. I can read it to you. But I'm going to ask you to compute the left-hand side and the right-hand side where we make some changes in the variables. And you won't understand what I mean by LHS and RHS unless you've read Chapter 2, and you, at least if you've read pages 32 to 54 that are the background for the case. So we're talking about the left-hand side and the right-hand side of the constraints that we will be building in. So what I do, I'm going to do this. I'll copy all of this, okay? And I'm going to put it into the PAR file that I downloaded. By the way, you should have solver. But before we do that, just checking on that, I'm going to go ahead and I'm going to I'll put my cursor down here and I'm going to copy that. Okay. And I will probably wrap the text and then squinch it out to where it's in something that's, yeah, I'm going to put it in a text box. This is going to be much easier. So I'm going to click insert. And I should find text box. Here it is. I'll draw my textbook. Then I'll put the verbiage in that's the problem I'm trying to solve. But just to help me, if you need it for reading, you can bold that up. Okay, so you're not looking at you're not trying to look at the thing online. This, you've got it in the file, and you just save it. And we'll be ready to go. Okay, so I've got the instructions here. Now, let's look at the file here for a moment. And again, this is based on Appendix 2.2 over on page 89. And so you'll want to take a look at that. This is a maximization problem. Now, let me stop for a moment. Now, if you don't have, well, let me click here for a second. Click on Data, click on the Data tab. You have Excel open, and you should have the Data Analysis tab, and you should have Solver. If you don't, you'll need to add Solver to you'll need to activate the Solver add-in. I apologize. So you'll click Options, then you click Add-ins, and Excel will show you the add-ins that are active and those that are not. Okay? And I have the Analysis Tool Pack, and the Solver add-in is active. Okay? If it's not active, it will be down here among the inactives. You'll just click it, you'll click Go, and it will show up over here in the Data tab as Solver. You remember, we've already worked over here with GoalSeek. And when you took 1123 with me, if you did, we worked with the Scenario Manager. The GoalSeek let us take set a goal and choose a cell where we wanted an output, then the goal, the value, and then the cell that would need to be changed to reach that value. Then in the Scenario Manager, as you recall, we took several variables, and then we clicked Show to see what it would look like, our results would look like if we followed that scenario. And we could name them 1, 2, 3, or whatever we did. Here, we're going to use the solver to maximize. Okay? Now, again, the textbook will take you through explicitly, step by step by step, starting on page 89. But you really should read the 32 pages 32 to 54 to understand fully about what's going on. But we can fill in some of the blanks by doing this before we attack the problem. I'm going to click on Solver, and notice this file is already set up. So let's talk about it. And I'm going to walk you through the dialog box. Now remember, back in module number 1, I have resources for there for you on using Excel Solver. And you've got the book. So it's when the authors walk you through the process of doing the math, the objective function, the variables that will need to be changed, okay, the constraints, that linear algebra problem that you can then, once you get a solution, you can graph it. Solver will do that. You can do that with Solver without having to resort to doing the linear algebra. The linear algebra lets you see a visual picture of the result area or the result set. For my money, I don't know that it does you a whole lot good to sit around and do a bunch of linear algebra and burn up graph paper and do that. If you want to do that, fine. But the truth is, when we're optimizing, you have a tool like Excel, and there are other optimization tools out there. The key thing is you're the decision maker. You need to be the one who knows what to input here. So this is a company, and they've got an operation, and they've got some constraints, and they're trying to deal with it. So we're going to start first with the solver dialog box, and that's this jewel right here. Okay? And let me get ourselves a little draw tool. And first thing is the objective function, which is a fancy way of saying, what is the answer that I want? And that's B18. And we want to maximize our total profit. Now, how do I know? We chose to maximize. And we provided ourselves a visual cue, another visual cue here, by simply typing that in. The next step here is I want to say, okay, what variables am I going to change? And the variables are B16, that array of B16 to C16. Okay? And we can scroll on down here, and I'm going to click that off for a sec. And I'll close this off for just a second. And we're going to roll down to B16 to C16. Okay? And I'll get that off there. And these are the two variables that we're going to change. The bags produced. And this company has two varieties. One is standard and one is deluxe. Okay? Now, we'll go back to Solver for a second. Now we want to maximize this value that's in cell B18, the total profits. And then I'll click the changing cells. Okay, and that's B16 and C16. And so we're saying, in order to maximize my profits, how many standard bags should I produce? How many deluxe bags should I produce? Well, our production of those two types of bags is dependent upon our restraints. Pardon me, our constraints, what we have in terms of time and materials and money. And so the whole idea of optimization is to say, okay, how do I achieve what's the best that I can do, or how do I achieve a particular goal given the resources I have? And the optimizer will tell me if there's what we call a feasible set, or if there is a feasible answer or not. So I'm saying, okay, I'm looking at that, B16, and then notice here are the constraints, okay? And it's subject to these constraints, B21 to B24 and D21 to D24. Now, before we look at them, okay, Here it gives us, here we have a set of, a table that shows us our constraints per unit. We have production time. All right. And this is, I think, 7/10 of an hour, or it could be 7/10 of minutes, probably an hour of cutting and dyeing for the standard. Then we have to sew it up. We have a sewing process that occurs. Then it's finishing, and then it's inspected and packaged, and it's ready to go. And we make $10 of profit per bag. The standard bag, the deluxe bag, takes an hour for cutting and dyeing. It's 83% of an hour for sewing. Basically 67% of an hour for finishing, but notice we've carried these all the way out. I think it's, well, I don't know how many places it is. And then inspection and packaging, and we make $9 profit per bag. Okay? Now, the variable that we're working with, okay, is time. How much time we have available. This is a company, they probably make more than just these bags with a standard and deluxe model. They may do nothing but make the bags, but they have constraints in terms of labor, and that's reflected here in the time available to do these tasks. And so if we look at this, to do the cutting and dyeing, we have 630 hours available, 600 hours available for sewing, 708 hours available for finishing, and 135 hours for inspection and packaging. And these are givens based upon the company. And the authors don't really walk us through, well, where did you get 630? They don't walk us through that information. But just as way of background, this is probably not the only product these people make, or if it is, then this reflects a particular order. Okay? And so we have these constraints, and based on them, here's the profit we have per bag. Okay? And these are the variables. These are how many bags we produce of standard, how many we produce of deluxe. And there we maximize our profit. Now we do this subject to the constraints. And let's look at this. This is the part that can get a little confusing until you just simply say, here are each of these processes. You can see we go from cutting and dyeing them, the raw product, to we do the sewing, the stitching, then we do finishing of some type, and then we do inspection and packaging, and the stuff's ready to ship. Now, I'm going to stop for a moment and see, anybody here have a question I could help you with? I'm going to assume a no response means you're understanding what I'm talking about so far, so good. You're probably saying to yourself, this cannot be this easy. It is. The reason that Excel invented the solver tool was to make it easier for you as a decision maker to spend your time focusing on the data that you need to collect, and spend your time focusing upon the results that you get. And so there's a report function in the solver, and we'll take a look at it just a little bit. So here's the left-hand side, that's the hours used versus the hours available. So we get a chance to say, okay, what did we plan? What did we have here? What did we actually use to produce these bags? And you'll notice I can click on that and it'll show me the equation. And the hours used is a combination of B5, which is cutting and dyeing, is at 0.7, times B16, which is bags produced, plus C5, okay? And C5 is going to be the time for deluxe, times C16, which is the number of deluxe bags produced. And that's where we get this 630. We had 630 hours available. Now, notice that we have some Boolean operators right here. And I'm going to go ahead and highlight those for you. Now, what this is saying is very simple. We have the following constraints. We can use up to, but no more than, 630 hours for cutting and dyeing. We can use up to 480 hours for sewing, but notice something. We still have 120 hours we didn't use. This is what we call a slack resource, and we'll talk about that a little bit later. One of the great things about this tool is this is a pretty simple problem. Think of this as we're seeing the summary of a bunch of work to figure out, how long does it take us to do the cutting and dyeing, the finishing, and all that stuff. There's a lot of work that goes on before you get to this point. But notice we've already identified that I've got 120 hours of slack time that I could use for another project or for another process. Then we have the finishing, okay? And I've got 708 hours, and my constraint is that's all I can use, and I use the entire amount. And then for inspection and packaging, I uncover another thing, and that is I had 135 hours available, but I only used 117. So thus far, I have some slack resources, and I'll identify them right here as on sewing. I have 120, and here I have 18 hours. So as an owner or a business maker or a decision maker, okay, I know, hey, I have some slack resources, extra hours, and extra time, extra hours for sewing, or I basically have 138 extra hours I don't need to use, but I can still maximize my profits. Okay? So the solver lets me see that. So when we talk about the left-hand side versus the right-hand side, the right-hand side says, what do I have available, or what do I have budgeted? And the left-hand side says, when I've done if I do a production run using these constraints and the variables, what does it actually look like to maximize my profit? Now I'm going to go ahead and we'll go back to Solver. So you click on the data view. All right. And I've got my objective function set up. I'm going to maximize. Notice if I want, I can minimize, or I can set a target value. And I've got the variables that I'm going to change. And the changing variables are how many bags will I produce of each type. And then I have the constraints. Now I can edit these constraints if I want to, I could make this a minimization problem if I wanted to try to do that, but I don't want to minimize profits. I want to maximize profit, total profit. So as I come down, I've done these three choices, and now I come to a fourth very critical choice, and that is select a solving method. Now there are three of them. One is what we call simplex LP. This means it's a simple linear programming problem. In other words, the data are distributed in a linear fashion. Okay, just like a linear regression. We assume that when one thing goes up, another thing goes up, or conversely, if one thing goes up, another goes down. Or if it goes down, the other, well, as one thing goes up, the other goes down. And think of an XY axis, and I can just show you real quickly here. No need to draw hand puppets. I'll close this off for a sec. I'll do a drawing tool. Okay. This is a simplex LP. Or, now later on, we're going to work with some problems where the data are curvilinear. They're either concave, the result set is either concave or convex. And so as you look in your text, they'll walk you through using the linear algebra to find what they call the feasible set, an area where I can find a feasible or working solution. In the old days, people would eyeball it using a slide rule. Today, you plug the data into a solver and it gives you the answer. If you're working in a simplex LP situation problem, then you have also a nonlinear, what's called a GRG nonlinear, and then there's one called evolutionary, and we'll look at those near the end of the course. Okay? Well, let's erase this for a second here. All right. Now, what I've said in the problem is, okay, compute the left-hand and the right-hand side, where the standard in cutting and dyeing equals 0.77, sewing equals 0.52, inspection and packaging equals 0.14. No changes in the deluxe. So I'm saying you're going to come over here and change these variables, operations here, and then the time available, and there will be no changes in deluxe, and then the time available here for each of these will be 0.95. And I ask you, okay, tell me, how many bags will be produced if you change these production inputs, amount of time consumed, excuse me, and then what will be the change in profit? Okay? That's what I'm asking you to do for the par ink. Plug this in. This would become of a 0.77. Now notice what I've done here. I've increased these variables. I didn't do anything with finishing, but I changed cutting and dyeing, sewing, and inspection and packaging. Okay? So it's taking more time to do the cutting and dyeing and more time to do the sewing and more time for inspection and packaging. But I only have 95% of the time available. And you'll plug those variables in and you'll run solver and you'll get the new number of bags produced and the total profit that you'd get. And so I'll ask you to tell me what changes we get in that. And then also, how will this look down here in terms of the constraints? Now, I want to walk you through just quickly about the output that Excel will give you. And one of them is this thing called the answer report. The text does a good job of explaining to you, okay, the result sets. Here's the target cell, okay, and the final value was 7668, okay. Then it says the adjustable cells. These are the variables, okay, and the original value was 540 for standard. The final value was 540. The original value for the deluxe was 252, and the final value was 252. This is the answer result. And then they show us something very important. You remember I mentioned earlier? Slack resources. When I can use this tool and identify a Slack resource, these are hours I've got available to do other things. I have 138 hours to take on some extra work or to move over to another project. That's what's so valuable about this. Now, I'm going to leave the sensitivity report. And let me say this, the sensitivity report is very much like a marginal report that shows us a marginal utility. You'll also see the term shadow price. And what that is telling us is if I find the optimal value, how much more do I save or make if I produce one more unit? Okay? Remember, I've taken the resources I have, I've used them as efficiently as I have. And when we use Excel, you remember I talked about this? We use models. We're using a mathematical model. I haven't done anything to my production line. I haven't hired anybody. I haven't done a single thing. I've built a mathematical model that tells me if I want to get that final value, here's what I use in terms of hours. And this becomes a tool to guide me to get that accomplished. The sensitivity report, and we'll talk about that some more. It shows us, okay, in order to stay within the feasible region or a feasible answer, I can decrease. I have allowable increases and decreases in the number of standard bags. I've got an allowable increase in terms of the deluxe bags and an allowable decrease in the number of deluxe bags. And you can see. And I can, and here's what I can decrease or increase and still remain at that value, still remain at maximizing profit. Then you can see these values of the shadow price. And what this is saying, for every hour that we save, for every unit, we save $4. When we reduce the time spent cutting and dyeing. The finishing hours, same story here. And we can see how much time can I decrease this, the cutting and dyeing, before I slip away from that maximization value. Same thing with the sewing. Finishing hours, allowable decreases. Here, these increases, you can see. But this helps you put that into perspective if you were to say, okay, well, what does this mean in terms of the Slack resources that I have? And what do I get if I produce yet another unit? How far can I go with my constraints? So that's the PAR Inc. problem, okay? Now you'll really need to, you really need, if you haven't, to take a look at pages 32 to 54 to get the full explanation of all this, and then back in Appendix 2, page 89, to get that picture of, to see how it's done using, how to use the solver, how to do linear programming using Excel solver. Well, we've just done that. You've got this, you've got the book, and then I have a resource there for you to take a look at. Now, I'm going to come back up here for just a second, okay? And this is the assignment. This is due on Friday at 5, okay? Now, let's go back to the modules for a moment. Now, let me stop for a moment and say this. I do this course in what I call a workshop or demonstration format. I'm more interested in you understanding what you're doing than I am in just having you parrot me with keystrokes. So, do the work, try it, make sure you use the constraints, change them as you should, and then upload your result, okay? And you'll get credit. Now, let me say this. As we move through the course, when we come down to the point where you have some projects to do, if you haven't been paying attention and if you haven't been working with these problems, okay, it'll come back to bite you. So you can rock along, but I guarantee you, you'll come to a point you'll go, I wish I'd been paying attention. So it's good for you to see, I'm giving you an opportunity to learn with this and play around with it. And then next week, I'll just briefly go through a solution file that shows you how things should have looked. Okay? But I want you to try it. You won't break it. And then you can try and then upload your file for the credit. Now we have a second one here, and this is M&D Chemicals. Okay? And we're going to take a look at it for just a second. And that's over in pages 54 to 59 over in your textbook. All right, now you already should have downloaded M&D. You should have already downloaded it to your desktop. So I'm going to do the same thing I did with PAR. I'm going to copy this verbiage here. Okay. And I'm going to come down to M&D Harmon. I'm going to open it up. Okay. And here's M&D Chemicals. Now, you'll find the background for the case. Let me insert the, I'm going to insert a text box. And then input the verbiage. There you go. And again, you might want to bold this up. Now, what I ask you to do here is for M&D Chemicals is to find the left-hand side and the right-hand side if processing time is increased 19% per product, and if the time available is decreased by 8%. So you've had the nightmare scenario. You have the processing time goes up. The time available goes down. That's why I call it a nightmare scenario. You say, well, okay, in practical terms, Dr. Harmon, how might that happen to me? If I'm running a place that makes chemical additives, or I'm running a restaurant, or I'm a division manager for a logistics company, and I've got to make sure that I have vehicles that can handle the load that comes in the door. If you get 800 packages that need to be delivered and you have a van, you're in trouble. You better have a semi or a large, you'd have to have a semi-trailer for that much stuff. So this is the kind of problem, kind of a nightmarish thing where the prices to the amount of time to perform a task goes up, but I've got less time to get it done. It can be a rush order. I might have a constraint set where I've got other projects going on. Okay, I'm not just rambling here. I'm trying to give you kind of the real world context in which this kind of thing rears its ugly head. So we're looking at here the processing time, and then the time available, and then I'm going to ask you to go ahead and run the optimizer. Now, let's go ahead here for a moment, and I'm going to click on data, and I'm going to click the solver, and notice here we have a minimization problem. You say, how do you know? Simple. The little dot button's pressed. Now, our objective function, i.e. our answer, is here in B17. We want to minimize total cost. So now we're working with a minimization problem. Now we still assume that we're working with a linear program, just a linear distribution of the data. Okay, and so we're working with simplex LP, and the changing variables are B15 through C16. That is the gallons produced, and I want to minimize it subject to these constraints. And this one's a little bit different this time. So let's go down here and look at the left-hand side and the right-hand side. Notice what we got going on. And I'll highlight these Boolean operators for you. You can see what I mean. Now, how much we produce is based upon the demand. In this case, we're given demand as constraints. The demand, we have two constraints here. The demand for each product, the demand for product A, the total production, and then the processing time. So we're focusing on product A. Well, we have these three demands, and notice for product A, we have a demand equal to or less than 125 units. Okay? We don't believe we have a demand for any more than 125 for product A. Then we have a total production time of 350. Total production for units of 350. And then the processing time is 600. And notice this is equal to or lesser than, equal to or lesser than, and then the authors throw a curveball at us and say we have to have 600 or fewer hours of production time. So it's a little bit of a curveball that they've thrown us here in terms of the production time and the way these Boolean operators are working. So I complicate it just a hair by saying, okay, the processing time is increased 19%. So it'd be 19% for product A and for product B. And the time available is decreased by 8%. And so I'll ask you to take the file, make those adjustments, and upload it, and then I'll go over the key with you. But the main thing, again, the reason you want to use a tool like Solver, all right, is that it lets you focus on, and I'll say that you're hearing me say this many, many times, it lets you focus on, number one, the inputs. How good are these data? And number two, the output. What are the results that I get? Okay? And so here you're in a situation where the processing time has gone up and the time available has decreased by 8%. The decrease in time could be, as I mentioned, you may have to siphon this off to another project. This may be something where you only have that 92% of 600 hours in order to get the stuff made and out the door. Made so you can get it ready to get it out the door. Now, I'm going to assume that you've had the production and processing course, project management course. I hope you have. If you haven't, then I want to take just, whether you have or not, I don't care. I'm going to make sure that we see what we're dealing with. When we're in production, we've got a series of events that happen. We have materials, I'm just going to call this M, that come to us. Now, this arrow means the stuff's in transit. It arrives at my door, and I have received it. I have to receive it somehow. And I either store it, okay, or I send it on out into production. Okay? Then I'm going to put it into outbound, where it's stored as inventory to be pulled and sent out, or where it's loaded on something and away it goes. Okay? So the time available to make the stuff, okay, this is the production time, becomes absolutely critical. If I have a customer who places an order with me, I've got to know that when it hits outbound, that then there's what we call transit time. That's the time to my customer. Now, I'm going to put in a short plug here, and I'm sure I'm probably burning up the time. Yes, I am. But you can always watch the end of this. You don't have to stay if you've got another class or whatever. I would say this. If you are at this point in time looking ahead to graduating and you don't have a job, I'm going to give you two recommendations where I believe you won't go wrong. Number one, it wouldn't kill you or hurt you to go check out Enterprise Rental. Enterprise hires more college graduates than any other company. Enterprise is a great way to get some experience working with the public because it's retail, okay? If you're willing to travel, if you're willing to be assigned anywhere they might assign you, it might be a chance for you to get to see some places you might not ever get to. And they have a great policy of promoting people from within. And if you move up to the point where you run one of their stores or you become like a division manager, you're going to do very, very well. It's hard, and they're a demanding employer. But let's say you work for them for just a few years. Suddenly on your resume is Enterprise Rental, a Fortune 500 company, a well-respected, highly successful company. A prospective employer will look at you and go, I got a live one here. It's the big leagues, okay? Now, if you are looking around and you still have some of those uncertainties about a job, let me suggest just a field or a type of employment in general where I think there's great opportunity for you, and that's in logistics. I don't care how much stuff you sell on Amazon. You've got to get it to the customer. In a global economy, logistics is that piece of the value chain that's the most critical. If people make stuff that they sell online, their vendors have got to get the stuff to them. And once they've worked that process, then they've got to get it to the customer. Logistics is a great area of opportunity. The two big companies are FedEx and UPS. And I can tell you something about the branding on your resume. My wife graduated from Southwest Baptist University with a degree in art. She took a couple of courses in office administration, they called it at the time. She landed a job at Target, worked for them for a while, and then she jumped to FedEx in St. Louis. And we've been living here now for 13 years when I came back to Oklahoma to go work at OBU. And she still has people calling her because that FedEx branding on her resume says, this is a person who knows how to do things. They've worked for one of the top companies in the world. Okay? So check out logistics. There are some great and exciting opportunities out there for you. And they start, some of the students I've had have come back and said, hey, I'm working in logistics, said they're starting at some pretty good salaries. So I encourage you, give you a couple of pieces of advice. Well, folks, I think I've covered these sufficiently. You've got the textbook there as backup. You've got this video, which you can play and replay. I'm going to post this today. I'll process it and post it. And then I will be seeing you Monday, and we'll have a live class session, ground-based, and I'll go over the solutions for each of these and talk about them. But try them and do them, okay? You get the points for trying them because I want you to start to work and move towards getting an understanding of what we're doing when we use this process of optimization and the problem-solving process that we follow, okay? So thank you very much for being here, and I'll erase this stuff I created, and we'll call it a day. I look forward to seeing your work that's due. Before I close it off, anybody have a question? Okay. Thanks much, folks. Have a good one.